Hi, thank you very much for your interest in our work, accounting for over-reliance in AI-assisted performance studies. This work is conducted by me, Weina, and Professor Ghassan Hamarneh. So this work is motivated by the question on how to interpret performance gain from AI-assisted human evaluation studies. We want to conduct a critical analysis to improve the scientific rigor in the evaluation studies. Our scope is limited by the follows. Our work focuses on AI assistants that perform the same task as the users. When we talk about the task performance, we refer usually to the metrics such as accuracy as an agreement between the decisions and with some correct answers. So let's first look at a typical study design paradigm. So usually in the AI-assisted human evaluation studies, we want to test if the AI has shown its utility by comparing users' baseline performance and when user are assisted by the AI, and we compare the performance in the two conditions. So if there's some statistical improvement for the two conditions, the study usually concludes that the AI assistant has shown a positive effect by helping users to improve their performance. This paradigm sounds very intuitive, but our study shows that this paradigm is actually flawed. To see the reason, let's look at this causal diagram. So here we have this independent variable of the conditions with or without the AI assistance. And we have the dependent variable measured by the performance. So from the independent variable to the performance improvement, the usual explanation is that is explained by the mediator factor of appropriate reliance on AI, meaning that when users are using AI, they have appropriate relying on the AI. When the AI is correct, they rely on AI. When the AI is incorrect, the user don't rely on AI so that they improve their performance. This is the one valid way to explain the phenomenon, but there's another also valid way to explain. This is a mediator of over-reliance, meaning the user rely on AI whenever AI is correct or incorrect. For example, suppose in a test, we want to test the students' improvement after the UI assistant. If the AI assistant has a superior performance than the students, then maybe the student can over rely on AI. They just put whatever AI says and put in the exam, and they can also get the performance improvement based on that. From this case, you can see that over-reliance can also explain the performance gain from the AI-assisted study design. And this is a negative effect because over-reliance can lead to long-term consequences such as reduced human autonomy and professional de-skilling. Next, we'll showcase a real-world case study to show the existence of over-reliance. But before that, let's first quantify how we can measure the over-reliance rate. So here you can see this confusion matrix to measure the users' reliance on the AI. So we calculate the over-reliance rate as a similar way when we calculate the false positive rate. So here, this is the Euro confusion matrix we see in the classification task. This is the actual prediction, and this is the predicted prediction. From this table, we can calculate the false positive rate as the portion among all the real negatives, how many are false positives. So here, so we compare the same calculation and we calculate the over-reliance rate. It is defined of among all the incorrect predictions from the AI, how many are wrongly accepted by the human, calculated as wrong acceptance divided by the wrong acceptance plus the right rejections. So our definition of calculating the over-reliance rate is a little bit different from the definition of over-reliance. So the previous over-reliance definition is defined by the user's acceptance of AI predictions whenever AI is correct or incorrect. But here we just use the same way as we define the false positive rate. The reason is that from this definition, we can see that the over-reliance rate is independent of the AI error rate or performance, so that we can compare the over-reliance rate among different studies. Yeah, so that's the consideration. We adopt a similar fashion as a false positive rate to calculate the over-reliance rate. So similarly, we can calculate the under-reliance rate using the similar way we calculate the false negative rate. And also, we can also calculate the appropriate reliance rate the same fashion as we calculate the accuracy here. Okay, with this definition of how we calculate those different rates, let's look at a concrete example. This example is from our previous study. In this study, we want to test the clinical utility of AI in helping doctors to improve their clinical task performance in interpreting the brain tumor MRI images. And our study shows that this is a doctor baseline when they are reading the MRI alone and make this binary decision whether this is a low-grade or high-grade tumor, and they reach average accuracy of 82.5. And when doctors are assisted by AI prediction, their accuracy increased to 87.7 with significant difference. And we also record the doctor's fine-grained decision for each of the MRI image interpretation, as you can see here. So here we show the baseline in full scenario when the doctor is right or wrong and AI is right or wrong. And we also record when they are assisted by the AI, whether their assistant judgment is right or wrong and the AI alone is right or wrong. So in this way, we can actually calculate the over-reliance rate and under-reliance rate and appropriate reliance rate as follows. So here you can see we corresponding to this confusion matrix, we label those four different scenario as right acceptance, wrong acceptance, right rejection, and wrong rejections. So let's first look at the baseline calculation. This is a baseline when doctor hasn't used AI, but we just calculate the different rates as a baseline comparison. So here you can see the right acceptance is when AI is correct and doctor correctly accepts the AI. And the right rejection is when the AI was incorrect and doctor correctly rejects these incorrect decisions. And similarly, when the AI was wrong and doctor should reject the AI, but they didn't, they agree with the AI. So this is a wrong acceptance. And similarly, when AI was correct, the doctor should accept them, but they wrongly reject them. So this is the wrong rejections. So we have these four numbers here. Next is here, this is the number of instances, and we can calculate these rates. So this is the baseline rates. And similarly, we can calculate for the condition when the doctor is assisted by the AI prediction. As you can see here, those are the three ways. So let's compare the results among those two conditions. So as you can see, compared to the baseline, their appropriate reliance rate increased from 82 to 86. So for the appropriate reliance rate, the higher the better. That means the appropriate reliance can explain the performance gain. However, you can see for the over-reliance rate, there we also have increased compared with the baseline. For those two rates, the lower is better, but you can see for because we have the increased over-reliance rate, that means the over-reliance also plays a role to explain the performance gain from the AI assistance. So from this case study, we showed that over-reliance, this phenomenon, can coexist with appropriate reliance that both explain the performance gain from the AI assistance. So that indicates for us that in the future human AI collaboration studies, we cannot simply assume that performance gain is due to users' appropriate reliance, and we should account for the over-reliance factors in our study design, analysis, and reporting. So therefore, we suggest three main changes in the human AI collaboration studies to account for the over-reliance. So the first suggestion is that we suggest that maybe we can, instead of using the performance gain that is a mix of appropriate reliance and over-reliance, we can instead use the other endpoint called a complementary performance. So this performance is defined by when the user are assisted by the AI, their performance is higher than either user or AI alone. So this is because this complementary performance is a strong indicator for appropriate reliance. So maybe in the future study, we can use this as a new endpoint and get rid of the performance gain endpoint so that we can have a stronger indicator for appropriate reliance and mitigate the negative influence of the over-reliance. And secondly, considering that over-reliance cannot be completely eliminated and can only be mitigated. So in the future study design, the researcher is responsible to control, measure, and report over-reliance rates in their study measure and reporting. So specifically, regarding the AI system design and study design, those AI system or study design should encourage users' skepticism by enable the system to be reliably indicate its limitations, scopes, weaknesses, uncertainty, and evidence for the AI suggestions so that users can more appropriately decide whether they should rely or doesn't rely on the AI suggestions. Also, in the study measure and reporting, we suggest the study also collect data on participants' agreement or disagreement with AI suggestions, similar to the way we show in the case study, and so that we can measure and report the over-reliance rate and compare among different studies. Lastly, if the performance gain is used as the study endpoint, we suggest that the study discussion should explicitly discuss the role of over-reliance in explaining away the mechanism of performance gain, and to disclose that the performance gain cannot be totally attributed to the positive aspect of using AI, but can also include the negative aspects of using AI for over-reliance. So that's it for our paper, Accounting for Over-Reliance in AI-Assisted Performance Studies. We hope our work can be helpful for you to design your future human-AI collaboration studies and to improve the scientific rigor of those studies. Thank you very much for your interest.